Okay. So what does the question say? A pneumatic cylinder pivoted at F operates under the lever AB of the toggle clamp, which clamps determine the clamping force at G. So this is the unknown. Now our free body diagram looks like this. This is free body diagram of member AB, ED. ED is a two-force member, and C. Now, if you directly, I cannot find CG because there are 5 unknowns in this. So what will you do is, first of all, using basic trigonometry, you can find out the angle that ED is making with respect to the horizontal. It will come out to be 20 degrees. Okay, based on this figure. Now, look at the free body diagram of member AB. It has 3 unknowns: FED with a certain direction, AX, AY. Find out the value of FED by taking moment about point A. Then come to free body diagram of CDG. We want to find out the unknown G. FD will be known. Take moment about C, get the value of G. That is your answer. Clear?
So can you explain once again, sir?
Yeah, okay. So in this one, ED is the two-force member. Okay. The first thing I propose to do is I will find out the angle ED is making with the vertical. For that, EDA is a isosceles triangle and ED is making 10 degrees with this AB. So I find out that ED is actually making 20 degrees with the horizontal. This is basic trigonometry. For an isosceles triangle, the external angle is equal to the sum of the two equal angles. Okay. Now I am drawing the free body diagram of member AB, CG, ED. Okay. AB free body diagram looks like this. This pneumatic cylinder is giving a normal force P. E has some reactions, A has some reactions. Similarly, CG's free body diagram looks like this. C is a two-force member, C is a pin joint, D is a pin joint, normal reaction at G. ED is a two-force member whose direction we know by our trigonometry. Now, look at member AB. Take moment about point A, you can find out the magnitude of FED. After you find out the member of FED, then you know the value of dx dy, or you can start with FED only. Then look at free body diagram of CDG. Take moment about point C. You will get the relationship between FED that you have found out and G. So you get the numerical value of G. Okay? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Good.
Yes, sir.
There was also some doubt about question 4, is it? Which one is question?
Yes, sir.
Yes, sir. Question number 4.
Question number 4 we discussed in detail last time, no? This is question number 4, yes? Is it?
It was discussed. Yes, yes, sir.
Yes. So what is the doubt? Please tell me. Yes.
Sir, the thing that you have encircled as for using that, but the moment about every point was cancelled. When due to FBG and FGM because they were equal.
I don't understand. So we took, so making the section is clear, yes? So if you could not do it, did you try other sections like the blue line and the yellow line that we? So you took a section like this and then what happened? Then what is the problem? Yes?
Sir, I tried with this also, but the solution, but I was not able to solve properly.
Why not?
I
Then
I said I had already spent a lot of time in the encircled one, so I didn't try. I'm sorry.
okay, let us do something. I think it is straightforward. We discussed in great detail. So let me find the solution. I will scan the copy and upload it in Teams. Okay.
Okay, sir.
Okay.
For this question,
Yes.
sir,
Sir?
we can also, sir, can I try to give it in the chat if I find it?
Okay. Anybody can give. Let's all collaborate.
Sir?
If nobody can do it, I will solve it and I will scan the copy and I will upload it. Don't worry.
Sir, is it possible to solve it using the encircled solutions that you have in PPT? Can we
I
solve
think-
it in that way?
I think so. What is the problem if I do it like this? If I take moment about point M, but it has 4 unknowns, is it? Is that the problem?
Yes, sir, because when we solve about point M or point D, the moment of FDC and FGM cancel. And the summation Fx is also 0. So these two are equal and opposite in direction, and if we take moment about any point, then these both are cancelled. So we don't get the values of FDG and FGM in this way.
Okay, let me look at this. Let me look at this. I will send you detailed solution of question 4.
Okay, thank you, sir.
Okay. Can I close trusses and frames then, if everything is okay?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Now, let us look at friction. Okay, friction doubt clearing will happen. So I don't want to do many doubt clearing. And then let's look at some problems. If in the middle of the problem we come across some concepts, we will discuss that concept. But from the feedback that I have already got from some students is that whatever was taught in the friction video, most of you already know, is it? This is something that you have already covered. Yes or no?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
There was
Just
very
the
few-
Yes,
rolling
sir. It was
coefficient
mainly the
was not covered.
yes, yes, sir.
which was not covered, rolling friction.
Rolling coefficient of something, friction rolling coefficient.
Achha, good. So ठीक है. Let us look at this problem sheet number 5. Okay. So this is, let us look at question number 1.
Also, sir, those screw with thread types of problem in question number, I mean, in the last two questions, 16th and 17, those type of questions also.
10 to 17, you can expect another video in the next few days about screw
Okay,
jam
okay,
and belt friction. You will have more on that.
okay, sir.
Okay. So let us try to solve question number 1. Okay. Just so that I understand maybe 50% of the class knows how to do it, but for the sake of completeness, let's look at question number 1. We will draw the free body diagram of this. Okay, it will look something like this, correct? Now, if my body is about to rotate, which components of force will be 0?
NB and FB.
And BFP.
So is this free body clear to everybody?
Yes,
Yes, sir.
Yes, sir.
And the idea that NB and FB will be 0 when it is about to rotate, that also everybody understands, correct?
Yes, sir.
Yes.
Okay, then how will we solve this? If the block slips, then NB and FB are not 0. So how can we solve this?
A moment about the point of tipping.
No, it is not tipping. When it is sliding, then what do I need to do?
Sorry. Then force balance on both the translational directions.
Which
Yes,
is
and
the
use F as F limiting.
which is the translational direction?
X
Yeah, I
X
mean, we
direction
do
for
fx and
forces.
fy, we do that, and
Yeah.
using the condition of impedance in motion, impedance motion, impeding motion, we solve this.
I have done fx is 0, fy is 0, and fb is equal to mu s into nb, fc is equal to mu s into
Yes, sir.
nc. And then if we solve, we
Yes.
should get the answer. And when it is about
Yes.
to roll, nb is 0, fb is 0. Yes, okay.
Yes, sir. Yes, sir.
Yes, sir.
Okay, good. So question number 1. Then question number 2 is similar, yes? Anybody who could not do question number 2?
Sir, I don't know why, but my W is coming the same, but it's negative. It's coming negative. I don't know why.
Negative means we have to apply upwards.
Yes, sir, but it is not possible enough for like
Yes,
W
sir,
has to
same.
be applied
Same,
downward only.
same. I also getting negative.
The massless link would push the block.
Is this the free body is this free body diagram correct?
Yes, sir.
Yes, sir.
And then what
Yes.
did you
Yes,
do?
sir.
So net force on the block B is 0 and net force on the block A is 0.
So force B is in equilibrium, block B is in equilibrium, block A is in equilibrium, yes?
Yes.
After that, summation, what is the value of N2 that you are getting? So look at block B, what is the value of P? So basically, I have solved it like this. I took block A, found out the value of P, and from P, then I look at block A, found out the value of WA. Is that what everybody has done?
Yes,
Yes,
sir.
sir.
What is
Yes,
the
sir.
value of P? What
Yes,
is the
sir.
value of what is the value of P?
It's 0.15 times the W I was getting.
P is equal to 2009 Newton.
Yes, sir. 2009.25.
Yes, sir.
2009.25. And then focus your attention on free body of diagram of A. Then what will happen? If P is equal to 2009, find WA. How will you do that? You will do Fx is 0, Fy is 0, yes?
Yes, sir.
Yes,
Once we
sir.
find out the value of P, I will focus my attention on this free body diagram. I will do Fx is 0, Fy is 0, and then P is, I'm not getting a negative sign, I don't know. Our approaches are identical. How did you get negative sign?
Sir, I think they have taken the direction of P negative.
I think they have taken direction of W is upwards positive. W is,
No, sir. That one I had taken down only, but P I had taken in the opposite direction.
Acha, okay.
Yeah, that's right.
P has to be equal and opposite, huh? Because in this question, member AB is a two-force member.
Yes, sir. Actually, P and F both I had taken in the opposite direction. That is why.
Okay.
So even so, we
Got it.
should get W similar, direction of W same.
Which one? Why should what be similar? Why should this be like this? Is it?
Sir, even if we take the direction of P different, the direction of, I mean the magnitude would be same and the sign should be same of WA.
They drew the free body diagram as this.
Yeah, it's just the opposite, but the
Then
Y
let me-
component are same.
If I have this P, then what will happen? Then if I have P like this, then is it a friction problem? Mu S, will it be in this direction, or mu S also has to be now be in the opposite direction? Mu S N1, if force was like this. But still, yeah, he's right. Why should the value of WA change? I don't know. I don't think it should come out to be negative. For some reason, it is something is wrong.
Yes.
Sir, it's
So
feeling like
maybe
tension
some
is
students have taken the value of P on A on right side, sir. Hence it is coming to be negative, sir.
Yes, sir. Yes, sir.
Yes, sir.
Sir, how can
Using
WA
P.
be negative means because
That's
it
what
will lose
No,
contact
it's
with the
in Y
surface.
direction.
even if you take it in this direction, even if this is even this blue is the direction of your P, and this force is not.
So due to that, so N1 will come to be negative, sir. Hence WA will become negative.
Yes, 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 yes. Because mu s N1 has to be in the opposite direction. Yes. If I apply a force
Yeah.
as it is in the direction of this blue arrow, then mu s N1 is correct only if N1 is negative. If N1 is negative, WA will also come out to be negative because N1 and WA are balancing each other out.
Yes.
Yes, sir. Yes, sir. That is only what my problem was.
But this is simple errors. You should not make errors like this. This is the free body diagram of member AB.
Sir, how did you decide that friction direction should be on the right side on block A?
Because AB is inextensible. I mean, the length of AB cannot change. So B has a tendency to come down. It cannot go up. If B has to come down and the length of AB cannot change, A has to come in this direction.
Okay, sir, got it.
Okay, okay, ठीक है. Good. So, and in this problems number 2, 3, 5, 6,
Sir,
all are
sir,
similar. 3 to 6
excuse
are,
me, sir.
yes.
So I think in third problem there is a need of dimensions of that, sir.
No, 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 no.
No, sir, it's all
Basically,
right.
mu s is equal to tan of this angle. N divided by mu s.
No, sir. I didn't require the dimensions.
So it
The
is
tan
tan
of
20.
theta by 2.
It is
Yes,
tan
sir.
20 degree, no? Or tan 10 degree. What is
Yes,
this?
sir. Tan of 10 degree.
Tan of 10.
Yes,
Yes,
tan
sir.
of
Tan
10.
of 10 degree.
This is very, very simple problem.
Sir, it was obvious, but how to derive that?
This
Net
comes
force
from,
on
I think, derivation. You can also do it something like this. Draw the free body. Let's draw the free body diagram of this yellow rod. Okay, yellow circle. So how will the free body diagram of the yellow circle look?
Fx equal to 0 I did and it came.
That's what I'm saying. So for that,
Yes,
just
sir.
okay. So this is our yellow circle. What are the different forces acting on it? I will have this is N, mu n, and similarly on the opposite direction also. Okay. Is this correct? Anything else? And this angle is 10 degrees. You can do summation fx is 0, summation fy is 0. You can solve and you can still get the value of n. Mu s, I mean. So, text box. N.
Sir, can we consider the bottom line to be horizontal and then from horizontal we will take 20 degree above and then solve?
Yes, yes, yes. That is just, I mean, it is a question of just your coordinate axis system. Yes, you are defining your coordinate axis system like that. Defining coordinate axis system is allowed as you want it.
Yes.
This is nu s into n. This is nu s into n. Now, if you do summation fx is 0, fy is 0, you will still get the answer. Even if you don't want directly that nu s is tan of 10 degree, free body will look like this. Summation fx is 10 will give you 2 into mu and cos 10 degree minus n sin 10 is equal to 0. Mu is equal to 10 tan degree. Mu is equal to 0.176. Okay or not okay?
Sir, sorry, sir,
Yes,
but I
sir.
didn't
Okay.
know NUS stand.
X-axis.
What is this?
I'm saying this is x-axis.
Sir, he's asking about what is NUS.
Friction coefficient.
Okay, sir.
I have to look for the symbol. I don't know where it is actually in this presentation exactly if you're looking for. No, it should be somewhere. Now it's okay? Now in this, do summation fx is 0, you should get the answer. Okay, is this clear?
Yes.
Sir, if we do the horizontal line, means
Yes,
the
sir.
bottom line as horizontal, then the NMG and the normal from the bottom line will be in the same direction, no? And that cannot be possible.
Are you saying that this should be my coordinate axis system? That you are saying it should be something like this. Is this what you want to do? Is this so? This parallel to this is my x-axis. This is my y-axis. Is this correct? Is this what you're trying to do?
Yes, I'm doing like that.
And then
And then I have means sir, I have made that horizontal also, means in my plane also I made that horizontal, and then my MG and that line would coincide. Normal from the plane would coincide.
which is m?
MG of that ball, weight of that ball. Sir, I will send the picture in the chat.
Take, please. We'll have a look. Normally, the choice of coordinate axis system will not change your answer. That is not possible. ठीक है. Try to solve, otherwise let me know it. Okay. So, question number 5. How many of you could do it? How many of you know what is a rear wheel car and what is a front wheel drive? What is the meaning of this term?
Sir, does that mean that the engine directly transmission is connected to the front wheel in case of
Yes,
front
sir.
wheel drive, and in the case of rear wheel
Yes,
drive,
yes,
it's
sir.
connected
I
to
use the same
the
technique.
force.
Torque
The
is provided at the rear wheel
yes,
or
sir.
the
Torque
front.
is shifted in case of front wheel to the front wheels, and
Yes, that is right. So, in a front wheel drive, the net torque is applied in the front wheel, and in the rear wheel drive it is applied in the back wheel, which is in turn then trying to push. So if you have a front wheel drive, torque is applied in the first wheel, it is trying to pull the rear wheel. If you have a rear drive, the torque is applied in the rear wheel and it is trying to push the front wheel. Okay, I think the free body diagrams would look something like this. So this is the front wheel drive, this is the rear wheel drive. When I'm having a rear wheel drive, the torque is applied on the rear wheel which results in a push Q to the front wheel. Okay?
Yes,
And
sir.
in the second case, you just have a torque here and you are trying to pull it. And we want to find out the value of H. How will you find the value of H? Let's say if it is a front wheel drive.
Sir, torque should be 0.
We will say summation Fx is 0, Fy is 0. I mean, this body should be in a state of equilibrium. Yes, the wheel.
Sir, I did not get what is the heighted part.
Which is the heighted part? This one.
No, sir. In the pavement in which the wheel is there, after some distance, you have drawn a slightly more height part.
It is
At
this
which the yes, sir. Yes, sir.
It is this part. This H is the unknown. This part. Understood? It's like somebody's
Yes,
kept
sir.
a brick. Somebody's kept a brick in front of your car. Okay, so also this is just drawn for simplicity. This is not a correct free body diagram because we have not freed the body completely. And this is just so that you can see the moment M is applied such that it is a torque in this direction. So friction is in this direction. Now this body is in a state of equilibrium. So you can find out the value of H based on the details that are provided to you.
Sir, in case 2, why is there is no friction in front wheel?
There should be no. 1 minute. I think
Sir,
it is
the will be
the key factor. This is pushing it.
Yes, sir. Otherwise, if the force on the lower part of the wheel is there, like the friction is there, then there should be a friction force to balance the torque.
Yes, so since the friction in the back is the key factor. If you're applying, so when the back wheel will start rotating, this has to start moving. So this friction is the limiting friction.
So I don't think there should be any friction in the second case, because if it is about to get on the curve, then the contact at the bottom is just a photographic contact, and if that is so, then there is no force to balance the friction if we put there to balance the torque due to the friction. I mean,
That's why there is no friction only in the first
There is no friction
front
in the
wheel.
front wheel. There is some friction in the back wheel.
yes, sir.
And that's yeah.
No, I actually
Sir,
there was some asking about the friction. That's why.
Sir, but for impending rotation too, if the back wheel rotates, then the front wheel should rotate too.
Yes, that's why the friction in the back wheel is the key friction. This is
Yes,
the criteria
but
for impending or not impending.
if you are looking at the front wheel in free body diagram, then there is no force to create a movement about the heighted part. So we can say that there is no rotation as of now in the front wheel, but there is rotation in back wheel.
Back wheel, you're right. Yes. Front wheel, we are actually not trying to rotate, but trying to push.
But sir, there will be some friction from that pointed edge part where N2 is being applied. There will be some
But that is
friction.
not the key factor. That is not the friction which will impend motion. Impending motion will depend on friction on the back wheel.
Okay.
The rear wheel pushes and the friction at the rear wheel is the key. That will decide whether or not your object will move or not move.
Sir, I could not understand the second case. What is happening?
In the second case, the torque is applied in the rear tire, which in turn leads to a push for the front tire. So the front tire actually is not rotating, it is just moving.
So the means the external torque by the motor is M, and the body is like a two force member acting Q.
Yes.
Okay.
Sir,
Sir, one more thing. How can we say that the Q will be applied in the center of the wheel?
Otherwise, this body will not be in a state of equilibrium. This has to be a three-force member. Two forces are passing through the center. Q has to pass through the center.
Sir, what is Q?
Q is the
Connect.
push. Q is the push that the front wheel is getting due to torque applied at the rear wheel.
Okay.
sir, why there is no friction at the front wheel? I still don't get it because due to N2 there should be a friction. Huh?
But this friction in the rear wheel is the factor for impending or unimpending motion. That's why.
So that is the case we will consider, but in the front wheel, why there is no friction? G2 N2.
Because the front wheel is not rotating, it is going above.
So it can rotate due to force Q2, na?
No, it will not
Q
rotate.
increase.
It will not rotate. Front wheel is not going to rotate. It is just going to go above this. Rotation happens due to a torque. Now there is no torque in the front wheel. Only the back wheel is going to rotate and the first wheel is going to get pushed over it.
Yes, sir.
Sir, so in first
So
case,
rolling
there will be no friction in
rolling
wheel
friction is
2.
neglected. We are neglecting the rolling friction because the first wheel is not rolling. If you look at the load Q, it is not causing my wheel to roll. It is causing my wheel to move in front.
Oh, okay, sir. Okay,
Sir,
sir.
so in case 1, there will be no friction in rear wheel. Okay.
No rolling friction. Yes. And based on the answer, what conclusion can we make? Which is a better option?
Front wheel drive.
Yeah, if you have front wheel drive, we can overcome much bigger hurdles. However,
Front wheel drive is better.
if we had a hurdle here in the back wheel, if somebody kept a stone in between the two tires, then a rear wheel would be better. But in general, a front wheel is better. It's more likely that I will have an obstacle in front of my car rather than in between my car. Okay, okay, good. Question number 6, were you able to do? Question number 6, if you have not done, please try to do it because it is somewhat intricate. There are many things that are happening in this question. A clockwise couple M is applied to the circular cylinder as shown. Okay. Determine the value of M to initiate the conditions of motions where MB and MC is given. Now the friction that you have seen between cylinder C and the floor is different than the friction between M and the floor. Okay. And this is, what can we say about the contact between the cylinder and the block?
Frictionless.
It is frictionless because they did not say it is not written that this is rough, only the floor is rough. Be very careful that mu SC and mu SB are different. That I think year after year, this is what we see. This is where most of the mistakes are made. So at least let us draw the free body diagram. I will draw the outline. You guys will tell me what load or what are the different things that I have to do. Okay, so let's do something. Let's copy. There is some messages by somebody. Admit. Are you guys not able to enter this meeting? Is there some problem?
No, sir.
Somebody is saying that there's some problem. Meeting options. 1 minute. Huh? Who can bypass the lobby? People in my organization. It is given in question 6 that BNC is negligible. Yes. That's what I'm saying. Okay. So let's draw the free body diagram. Okay. So, in this circle, what are the different forces that will be there?
Two normals, one weight, two normals,
friction.
one weight, and friction plus the external M.
Some torque like this. Yes, or it was opposite actually.
Sir, the horizontal normal will not come into play unless the impedance motion is achieved.
What is impedance motion? Impending motion.
Sorry,
Impedance
I'm
is
sorry.
electrical engineering, right?
I'm sorry.
Getting-
The impending motion is achieved.
There is M, and what else? There is mg. What else is there? And
Two normals.
Control C, Control V. There is P, then something like this. Yes. This is
Yes, sir.
This is MCG, not Melbourne Cricket Ground, but mass of the object. This is P. FC. This is NC. Okay, yes. Is there anything else? Now, similarly in this box, what can I have? Equal and opposite P. MBG. And then what will be the direction of FB, right to left or left to right?
Right to left, sir.
Correct. And Control C, Control V, this is NB. Something like this, yes, everybody?
Yes, sir.
And can I write instead of FC nu s into NC? Will that be right or wrong?
No, sir, we cannot write right away.
No, sir.
So we have to compare between FB
I think
limiting
we
and
have to
SC.
compare
Yes.
both.
You have
Yes,
to
sir.
find both the
Mu
maximum limits
Then
possible and
compare.
take the minimum
and then
one.
we have to decide intuitively.
Yes. So actually, this was a question 2 years ago. A free body diagram was given, and they have to draw a free body, and the students had to choose free body diagram, which was like this. And large number of students wrote instead of FC, it was mu s into NC. So obviously, the free body diagram was incorrect. Okay,
Can you
now
please
what
explain again why it turned out to be incorrect?
it is incorrect because FC will be equal to mu S into NC only in the case of impending motion.
Oh yes, 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 yes. I got it.
Okay. So now what to do? How can we solve this problem?
Sir, first we'll find out FC limiting and FB limiting.
Yes, sir.
Then we'll compare. Then we'll find like FB limiting is less. So for impending motion, the P will be equal to FB limiting, which will be equal to FC. So and M can be equal to FC into R. So we'll put that there. So M equal to FB limiting into R.
Yes. So one by one, you will solve
Yes,
for
sir.
both.
Same.
Both the possibilities are there. One by one, you will solve. The lower value of M is the correct answer. Yes.
Yes, sir.
Yes.
Okay. Good. Okay. Good. Everybody understands these types of problems. It is very important to understand the different possibilities that are there.
Yes, sir.
Because usually people don't understand the different possibilities and you try to solve it assuming only one of the two possibilities, which invariably leads to incorrect answers. Number one. Number two, and due to time pressure, it is very easy to put the same value of mu SC and mu SB. That we have to be very careful. If different values are given in our calculation, that has to be accounted for. I think these are some very common mistakes that people have been making. Okay, anybody who does not understand
Direction
the
of
question
friction in
or
case.
yes.
Sir, here what are the two possibilities?
Possibility number one is that the cylinder starts rolling. Possibility number two is that the block B starts moving.
Sir, for the block B to move, the cylinder also has to move, right?
No, which is impending. So which is impending earlier?
Okay, sir.
Okay, good. Anything else? So questions numbers 3, 4, 5, 6 are similar, and please practice this properly. This is you should be able to you should at least be 100% sure about problems like this where there are circles. The different directions that we get. Hello, am I audible still?
Yes, sir.
Yes,
You're
sir,
audible.
you are.
You're audible, sir.
Yes.
Yes, sir.
Okay, good. So what else? What to do next? Question number 7 देखते हैं. Okay, I think I can manage for 15 20 more minutes.
So I'm not able to see the peg in the question number 7.
So actually in 7, sir, C point is at the peg, sir, which is not written on diagram.
A slender rod is between peg C. This is C. This the circle that you see is C. So let's see. This is C. This is the peg C. Okay.
Yes, sir.
What is the question? What does the question say? A slender rod of length L, which is this, is lodged between peg C and the wall. Okay. Theta is 35 degrees. Coefficient of friction is 0.20 at both B and C. Find the length of L by A so that equilibrium is maintained. Why is there a range? What are the two possibilities that can happen?
The friction may be acting in upward direction or in downward direction at the point B, sir. Hence, there are the range for L by A ratio.
Yes, let us try. This block could actually pivot around this to go like this, yes? If I don't look in terms of friction, in terms of physics, what are the two things that can happen? B can go up or B can come down. Correct?
Yes, sir.
So there are two cases basically. That is the whole story. That in one case it is rotating about C, the entire thing. The entire thing is actually. So the entire thing, this AB wants to become like this. This is one possibility. Yes, from 35 degrees, this angle increases to 45, 60 degree. So the rotation is about C. And the second possibility is simply that this wants to go like this. Something like this it wants to go. Yeah, these are the two possibilities. Yes or no? Just from a physics point of view. Without
Yes.
understanding friction,
Yes.
these are the two things that can happen. In each
Yes.
of the
Yes.
two cases, what are the free body diagrams? What will it look like?
Sir, the angle is constant.
Angle is constant, but I mean, we are trying to imagine after impending motion, what might be happen? What is the motion? What is the direction in which impending motion can happen?
Okay, sir.
We're just trying to imagine, not saying that the angle is changing. So in case one, what is going to happen? Let us draw the free body. Diagram.
Sir,
There
case
is-
one, we have considered B is going up.
Yes.
Okay.
There is P. What else? Tell me.
Sir, friction at B will be downward.
Yes, sir. Friction at B will be downward.
Control C, Control V. And
The friction at C will be along B.
needless to say, this is going to be X. And
So normal at C will be perpendicular to that rod.
this is mu C into N, mu into NC. And correct? Or should there be something else?
So weight of rod, sir?
Is it given?
So massless is given.
Slender rod. Nothing is given. We will assume it to be massless. The word massless is not written. Unless it is written, we assume it to be massless.
Sir, what do we mean by slender?
Slender means that the length by thickness ratio is very high.
Okay.
And what do we want to find out? We want to find out the ratio between these two lengths. So all the
So what did you mean by slender? The length by which ratio?
length by the width.
I mean, we can say that length by the diameter ratio as well for, this rod.
Is it a circular cylinder? Length by diameter, yeah, if it was assuming it to be circular, length by diameter is very high.
Okay.
Or the diameter is negligible as compared to the length, which makes our problem easy. If it had a radius, then we have to account also for the gap, then the calculations would be slightly difficult. Okay, now in the other case, the directions of what will change? In the other case, the direction of both the friction will be
opposite.
Will be opposite, yes. And what do we want to calculate? We want to calculate the ratio between A and L as shown in this figure. This A divided by L length we want to find out. For that, which equations of equilibrium do you propose?
Sir, moment equation.
Some
About
moment.
Moment
About
about B.
Moment about
C.
B
Yeah.
0.
Moment about?
About point B, sir.
Yes, sir.
If I
B.
take,
yes,
if I
sir.
take
And
moment
many
about,
of the unknowns would be unlimited.
then what? Take moment about B. What is the relationship you are getting?
PL sin theta is equal to N2A cos theta. If N2 is the normal at peg.
PL sin theta is equal to
N2 into A cos theta.
into A by sin theta.
A by sin.
One.
Yes, sir. A by sin theta.
Oh, sorry, sir. ये A by sin theta.
सर mg का टॉर्क भी तो आएगा ना?
Massless.
Massless. Mass is not given.
Okay.
But this just taking torque about B is giving me A by L in terms of P and NC. We have to find out the value of P and NC also.
So vertical force 0 and horizontal
And
force
then
0.
summation Fx is 0, summation Fy is 0. So basically the trick is take moment about any point that you like. You will get AL in terms of force P and some normal. And then you will calculate Fx is 0, Fy is 0, get the answer. Okay?
Yes, sir.
Yes, sir.
Yes, sir.
Anybody, this is, I think, straightforward. Now, after doing 2D and 3D equilibrium, this should be okay. As I mean, all of you have basic idea about friction. Combining what you know about friction and 2 and 3D equilibrium is normally, I think, at least the first half of this problem sheet should not be very difficult. Correct?
Yes.
Yes, sir.
Yes, sir.
Okay. Can I go to next question, or anybody has any doubts in this question?
Sir,
In first
direction
case,
of
both the
friction at
friction
C.
are above.
Wait, one at a time. Direction of friction at C is what is the question regarding that?
Sir, how did you decide?
By looking at this, we observe that there are two possibilities. Possibility number one, B has a tendency to go down. Okay. Possibility number two, B has a tendency to go up. These are two possibilities. And we will draw a free body diagram one by one. What happens if B has a possibility, has a tendency to go up? If B has a tendency to go up, friction in the B is this direction. Now, if B is going up, then what is the relative motion with respect to C? It is, tell me, yes. If this has a tendency to go up, at C what I am seeing? Relative to C, what is the tendency of motion?
The length CV shortens so that.
So that's why then based on this you can find out the direction of friction in the two cases, when B is coming up, when B is coming down. Clear?
Yes, and when we'll get the range for both those extremes.
Yes. As soon as somebody says range, it means that there are two possibilities.
Sir, in this question, where is the impending friction? Is it at point B or C?
It is both simultaneously, na, because AB is inextensible and the coefficient of friction at B and C is given to be same.
Okay, sir.
So I have a doubt, like if the coefficients are given to be same, like will we consider the impending motions at both the points to be like at both the points we will consider that to be impending friction all the time?
I think that when the rod will make that motion, the slipping width will occur at both the points. So there is no case of considering impending at one point, both would come on simultaneously.
It has to happen simultaneously. It cannot be at one and it cannot happen at
थोड़ी
the
देर
other.
से
It must-
हाँ ठीक है 1 घंटे मान देना मैं बता देता हूँ
So it's not possible, as he says, that it cannot be that it is moving with respect to one and stationary with respect to the other.
Sir, peg is here acting as a support.
Peg is sort of a support. I mean, to hold a stick, you need at least two points. Yes, so this is B and this is the point.
Sir, and what is supporting the peg?
Peg might be, I mean, if you look at it from this direction, so let us say you are looking at it from this direction. But if you are looking at, you are taking like a photo like a drone, then this peg will actually be a long rod which is joined to a wall. From the top view, peg C is a big rectangle which is connected to a wall. Think like that. Understood or not? Try to imagine how this structure will look if we look at it from the top. It will look like, let me try to draw. What will happen? You will look at, are you guys taking a course on engineering drawing? ED?
No, sir.
No, sir.
No,
Next
sir.
semester.
Next
Next
semester.
Next semester.
Sorry, next time it is.
That's why. Try to imagine what this looks like from the
Sir,
top.
we can consider it as the means inside a cage also there is a bird on some horizontal structure and the photo is taken from one side.
Yes. This member is the bird and this is the peg is where the bird is keeping its feet, something like that. Actually, now engineering drawing and mechanics should be in the same semester. It would be very useful. And for you also, it would be easy. For us also, it would be easy. But I don't know why it is not.
So I guess due to the fact that it will get loaded, that's why it's not there. I think so.
I don't know. Whatever it is, we have to make do with it. What can we do?
So we can imagine a bit though. Yeah.
Is it clear or you want me to draw it actually?
Sir, we can imagine
okay,
it
sir.
clear now. Clear.
I think you, or also not just to imagine, you can also imagine that you have a pencil, you are holding the pencil. Okay, with the nib pointing towards you. Imagine that you are holding a pencil with the nib pointing towards you and this peg AB is parallel to your shoulder. It is resting on a wall.
Yes, sir.
Okay, good. So last question, I think let's do one more question and then we'll call it a day. Question number 8.
Sir,
Yes.
9, sir, please.
9?
Yes, sir.
Okay.
Can you discuss that?
Yes. A5 wedge, have you studied wedge already? In the presentation given by Professor Maiti, was wedge discussed?
Sir, briefly.
Then wait,
Yes,
I think
sir.
wedge is also an engineering application, so he should normally discuss that.
Okay, sir.
Okay, sir. Okay.
Wedge is very interesting. Let me show you a picture that I use in the class every week. I'm stopping to share. And 1 minute, let me search for something. When you guys were small, have you heard the story of the monkey and the log? Have you read
What, sir?
stories of Panchatantra?
No, sir.
Yes,
Have you
sir.
heard the
Sir,
Panchatantra
Yes,
stories?
give a
All of you
little
have-
summary, sir.
We have
Yes,
read
sir, give the-
Panchatantra, but I
tell the
cannot
story once.
recall this.
Yes, sir.
Sir, in Monkey Log, I can
Tell us the
only
story, sir.
remember
So Panchatantra story is there is this story, you know, that at the edge of the jungle there are some carpenters who are working and there are naughty monkeys. And those monkeys, they started playing around with, this is a wedge. And these monkeys start playing around with the wedge. So what happens? This wedge comes out and their tail goes inside. And then they learned the lesson that they should not fiddle because it is impossible. Once a tail goes inside this wedge, it is impossible to take out. Remember, there is a very interesting story, and that you will learn also. I think after studying wedge, you will find out that
Yes, we
the P required to put this inside is much lower than the P that will be required to pull it outside due to friction.
Yes, sir.
But I think you will have.
So then P will be higher, sir. Can you tell once again?
P will be higher when you are trying to pull it out.
So I think push it in.
I think the story was na when we monkey की story में, if I can talk in Hindi for 1 minute, कि monkey को कहीं अपना पूंछ घुसाना easy है पर वो मुसीबत से निकलना मुश्किल है. The moral of the story was something like that. I think with wedges, you will understand this much better. That the story of the monkey and the wedge is actually based on physics.
Sir, is this structure something similar that we attach a separate attachment below some nails that we put inside walls so that it does not come out?
This is actually so that na, when the carpenters are cutting it, na, if they don't put a wedge, all their effort will go in waste. The wood will snap back to its original position. So before taking a lunch break, they put something like this so that when they come back, it is much easier to continue with the chopping of the wood.
Yes, sir. I have seen that. Yes, sir.
Okay. So one more interesting problem that you can, all of you also watch Hollywood movies, yes? Or some of you have watched Hollywood movies, yes? Holly.
Yes, sir. Yes.
I didn't watch March of Red, sir.
Yes.
Okay, but all of you know what a cowboy is?
On the Marvel movies.
Yes, sir.
Yes,
Yes, sir.
Yes, sir. The cartoons are enough for that.
So in
Tom and Jerry.
so in if you have seen what they do, a horse is about to run and the cowboy takes a rope and he flips it across some sort of log and the horse cannot escape. It looks something like this.
Yes, sir. Yes.
Yes, you can recall now what I'm saying. So this horse is wild.
Yes, sir.
To keep the horse in control, the cowboy has just flipped this rod over a piece of wood. So now the horse, and in the movies they show now the horse cannot escape. So my question to you is, do you think it is realistic? Do you think that we can tie a horse by this technique? Just by throwing a rope along a log?
Yes, sir. I have experienced this also. The like harder you
Yes,
pull,
sir,
the
I have.
more friction it gets.
Yes, sir.
The
The friction.
practical.
Yes, sir. Like if I
Yes, it is
stack
called.
two books together by their pages, their books don't fall. Even if I
Yeah.
hold just one of
The
them.
total
Yes,
contact angle
yes,
will
the
experience
total
friction.
Sir, there is an exponential relation related with that mu.
Yes.
Right, that's why, correct. So can you imagine what is likely to happen if our horse is very, very strong? The rope will break first, or the horse will escape, or the wood will break first.
Maybe sir wood, maybe or
So maybe
rope
the rope will
break.
Rope will
Maybe
break.
depends on
rope will
rope
break.
and
We will answer. I
so
mean,
horse
From
can
the
accept.
Depends on the strength of the rope.
Yes, sir. There is a breaking.
Sir,
But
a horse can
in
also slip, sir,
horse
if
can
there is
break
less
rope,
at
friction.
any cost, sir.
it is reached, it will break.
if I say,
Yes, that is also a case.
if I say that the mass of this rope is 50 grams, or if the mass of this much rope is, let's say, 50 grams, how much force does the horse will have to apply? Give me an approximate number. What do you think? How much? The mass of the rope that is hanging is, let us say, 50 grams. And how much mass do you think the horse will have to apply?
What is the coefficient of friction?
Take any normal, use your engineering sense. How much will a log friction have? Take some numbers. No need to do exact calculation. Just tell me, what does your intuition say? If it is 50 grams, the horse has to pull 10 kilograms, 100 kilograms, 1000 kilograms. How much?
So maybe 50, around 50 kg.
But horse can pull no 50 kilograms. In a horse cart, we put a load of 50 kilograms.
Sir, it will rise exponentially with the number of turns, right?
1000
Yes, sir.
kilograms.
It should depend on the number of turns too, sir.
Yes.
I mean,
it is
the
given
number,
the number of turns you can see.
3.
You will be surprised that it comes out to be around 650 kilograms. So the trick of the cowboy is how clever he is in how many turns he can make. He has to throw the rope fast enough that it takes more than 2-3 turns. That is the trick of the cowboy. So we'll solve, we'll solve problems like this, which will be more real life. Real life applications of friction. So the first week was almost everything that you know, but second week will be much, much more interesting. Okay.
So from which question we will discuss in next class, sir?
In the next class, we will start from 9. 9 is wedge. I think wedge was not covered in your presentation. So if I look at the friction problem sheet, let me quickly tell you what is what. So problems number 1, 2, 3, 4, 5, 6, 7, 8 are basics of friction, which we have covered so far in the videos. Okay. And also I think most of you know how to do it. We discussed a fair bit. Question number 9, question number 10 is wedge. Wedge is a lifting mechanism whereby applying a small amount of load, you can lift a large object. Both 9 and 10 are wedge. For example, this is, I think, look, for example, a 40 kilogram cylinder can be lifted by applying a force of 98 Newton. 40 kilogram is 98 into 4. So by applying a wedge, you can lift large amount of weights by applying small forces. So 9 and 10 are wedge. 11, I think, is basics of friction. 12, 13, 14, 15 is belt drive. When you have a belt drive, there is friction. So the tension in the two ends of the pulley are not same. This will depend on friction. The horse was an example of that, where one end was free, so tension was equal to the mass of the thread. On the other side, there is a lot of friction. So 12, 13, 14, 15 is belt drive. 16 and 17 is screw jack. 17 is screw jack plus wedge, both concepts combined.
Sir, we'll discuss this sheet again next Friday.
We will continue this sheet next Friday, and next Friday will be your assignment on friction. So
okay, sir.
Tomorrow, most likely, we will send you another video. Tomorrow, there is another video on friction on these interesting applications. And today, assignment on truss and frame is opened. Thursday, doubt clearing on the complete topic of friction by Professor B. Maiti. Friday is the second tutorial on topic friction. Friday, the assignment on friction will open. Okay.
So the assignment of friction will be like both the topics mixed.
Yes.
Okay.
Excuse me, sir.
Yes?
Sir, what did you say in the first 10 minutes of the meeting? I wasn't there.
First 10 minutes we were doing, I think it was just talking about the class test, exams, etc., etc.
No, like, did you give some instruction about
Nothing to do from your side. I just explained how how the assignment number 1 marking scheme has changed a little bit. I think that was the most important announcement.
Okay, sir.
And so the next test would be in February 6th, right?
Next week, yes, as announced earlier, February 6th. And yeah, problem sheet number 4, 5, and 6.
Okay, sir. So that means there will be another topic that will be taught after friction, which will be in the test.
Yes.
Okay, sir.
Sir,
Sir, we were taught that friction does not depend upon the area of contact. Then why on rotating many times the rope around the wood base, friction increases?
That you will discuss. I mean, we will learn once. Let the video come on belt drive. You will understand that. If you still
Okay,
don't
sir.
understand, next week we will discuss.
Sir,
Do you have the book by Beer and Johnston? Most of you have that?
Yes, sir, I have.
We have the PDF, sir.
Ah, PDF. Okay.
Yes, sir.
Yes, a PDF.
So in that section 8.5 is wedge. 8.6 is thread. And 8.10 is belt friction.
sir, can you
Like
repeat the name of the book?
the name of the book is Vector Mechanics for Engineers Statics by Beer, Johnston, and there are 5 more authors. Beer, Johnston, Mazurek, Cornwell, Eisenberg. And in this one, I think if you are interested to know more about friction before the videos, look at section 8.5, 8.6, and 8.10. 8.5, 8.6, 8.10. But if you, I mean, there is no obligation. You will still get a video on that. You will still get a presentation on that. So it's, the name of the book was given by me in the first class when I've given the guidelines. The title of the book was given, so you can look there also.
Sir,
Yes.
if you don't mind, can you please explain question number 5 again?
Question number 5. Yes. What did you not understand?
Sir, both the cases. What is happening?
So in question number 5, there was one a front wheel drive and then one there is rear wheel drive. Front wheel drive means that the engine is connected to the shaft in the front set of wheels. Okay. So the torque is applied to the front wheel. The front wheel is rolling and it is pulling the rear wheel. And in the second case, the torque is applied to the rear wheel and it is pushing the front wheel. So the free body diagrams look something like this. In the first wheel, you have torque in the front wheel, unknown is H. In the second case, torque is in the back wheel, which leads to a load Q in the front wheel, and you have to find out H. You have to keep in mind that normal reaction during impending motion here is 0. And there is no rolling friction. The wheel is not rolling. This was the question number 5. Main, I think, important new thing that you perhaps you have come across is front wheel drive. The torque is with respect to the front wheel. Case 2, rear wheel, the torque is with respect to the rear wheel.
Okay, thank you, sir. And sir, can I ask a doubt? Sir, I just have a doubt that in some questions we want to calculate torque about a point where torque is not centered, like that M is not
Right.
on the
But
point.
you have to account for that. But you have to account for that.
So, sir, that's my doubt that if we want to calculate torque about some another point, then the torque on the system will be M also.
Yes.
Torque doesn't change it when we change the point.
No, it will be there.
Okay, sir.
Prerit, thank you for sharing the PDF with your classmates. But be careful, huh? I mean, these publishers, they will send you notice. So, I mean, if I was you, I would not put it in a Google Drive for too long. There have been cases where inside the institute, we have received notice from the book publisher for illegally sharing and downloading books. So just be careful. Otherwise, I mean, logically, we should have given you the book, yes? I mean, if we have the soft copy, why would I not share with you? The reason is because it is illegal and we would get into trouble. So be careful.
So in question number 5, I have a question related to the question, but slightly outside the topic. Like it was given 60% of the weight is distributed over its front wheels, and 40% of the weight was distributed over its rear wheels. So why is the distribution not 50-50? Why is it?
Because the center of gravity is not the physical centroid of the car. The engines, etc., are towards the front of the car. So the center of mass is somewhere closer to the front tire.
Oh, okay, sir. Got it.
Sir, can you explain the coefficient of rolling friction, that A which has taken in account?
Which one?
Sir, in the slides towards the last part, there was a coefficient of rolling friction that the circular wheel always deforms a little, and the reaction acts at a distance A from the center of the wheel.
It is in the what? In the presentations that was shared to you, is it?
Yes, sir.
Next week, please ask Professor Maiti only.
Yes, sir. Yes, sir.
He will be there.
Yes, I think he was referring to rolling friction, where coefficient of rolling friction was given that it was shifted by a distance A from the actual position.
Okay. If you guys don't mind, I think I would like to close this class. We'll continue next week. Okay?
Yes, sir.
Yes.
Yes, sir.
Yes,
Thank
sir.
you.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Have a good
So
weekend.
get well soon.
Thank you, sir.
Get well soon,
Yes,
sir.
sir.
Get well
Yes, sir.
soon,
Get well
sir.
soon.
Thank you.
Thank you, sir.
Yes, sir. Get well soon, sir.